So in Chapter 17, we are going to go from two-dimensional figures to three-dimensional figures, solid figures. This is a very short chapter. It is only 2 lessons long. We will complete the entire chapter this week. The biggest thing in Section 1 is vocabulary. So this document is uploaded to Google under Chapter 17 materials. You can print it if you wish. You can pull it up and look at it whenever you want. I'm going to go over these and try to describe them using the words that obviously aren't written right here. So our first term is polyhedron, and that is a solid figure with faces that are polygons. It is not just a three-dimensional shape. Okay? It is a three-dimensional shape that is made up of polygons, which, if you remember from last chapter, a polygon is a shape, two-dimensional, flat, that is made up of line segments. So the big deal with a polyhedron is no curving bits. So like a sphere is not a polyhedron. A cylinder, a cone, they are not polyhedrons because they have curved bits. Now, like a cube or a pyramid or a prism, those are polyhedrons. They're made up of nothing but straight-sided flat shapes. When we talk about polyhedrons, or really any three-dimensional shape, we can talk about their faces. A face is one side of a three-dimensional figure. Like a sphere doesn't have faces because it doesn't have sides. Same thing, a cone, a cylinder, we wouldn't say that they have faces. Face is really meant for a polyhedron. So like if you had a cube, like envision a die sitting in front of you, it has 6 faces, a front, a back, a top, a bottom, and a left and a right. An edge is a place where 2 faces on a polyhedron meet. It's a line segment, guys. Again, if you were sitting with a die in front of you, if you run your finger along between 1 and, let's say the side that's between 1 and 2, that is an edge, the whole length of it. A vertex is a spot where 2, usually more, edges of a polyhedron meet. Okay. Vertex, think sharp, pointy bit. The part that, if somebody threw a polyhedron at you, you wouldn't want to take the vertex in the eye. That doesn't end well. Vertex, sharp, pointy bit. It's a single point. It's a place. Single point. Not a line segment. Not an entire face. It's a point. Okay. A prism is a particular kind of polyhedron, and for our purposes, we're going to say it has 2 congruent bases. And those bases will be connected by a bunch of rectangles. So a triangular prism will be 2 triangles, identical triangles, connected by 3 rectangles, because a triangle has 3 sides. It's kind of hard to say, 4-sided prism. So a cube is a special kind of rectangular prism. It's got 2 sides that are opposite that are rectangles connected by a bunch more rectangles. We can have 4-sided prisms that aren't rectangular. They're not very common, though. We're usually going to see rectangular prisms, which will have 6 rectangles going on somewhere, and cubes, which are 6 squares. And after that, we're talking about like pentagonal prism. That would be a prism whose 2 bases are pentagons, meaning it's a 5-sided shape on the 2 bases, and there are 5 rectangles connecting them. And we could scale up from there. Hexagonal, meaning hexagon bases, 6-sided bases, 6 rectangles connecting, and so on and so on and so on. The base are the 2 congruent shapes that form either the top and bottom, the front and back, or the left and right side of a prism. I can't be more specific than that because every diagram of a prism could be drawn facing a different way. So long as we're not talking about a rectangular prism, where there are 6 rectangles, the bases are the 2 shapes that aren't rectangles. And you'll know what I mean when you actually see some examples here when I go over to my pictures from the book. Okay. Lateral faces are the faces of a prism which connect the 2 bases. Essentially, they are all of the rectangles that connect the bases. And this last one I have because your book has it, but you don't really need to worry about it. A right prism is a prism where all of the rectangular faces meet the bases at 90 degrees. All of the prisms that we deal with in 6th grade, in 7th grade, even in 8th grade, will be right prisms. Okay? If it's not a right prism, and they do exist, then some of the properties get a little messed up, and we're not dealing with that. So if you have your textbook with you, you can turn it to page 498, and if you don't, I'm going to jump to page 498 because, book, I have it. So here's a picture of page 498. And all of those vocabulary words we just went over are here and highlighted in yellow. And they're showing us what these would be. So beside all these definitions, you see 4 shapes, and they're labeled rectangular prism, triangular prism, pentagonal prism, and cube. And they're saying that on these, the bottom is the base, which is fine. They can do that. In the rectangular prism, it really doesn't matter if we call the top and the bottom the base, like the book does, if we call the front and back the base, or if we call the left and right sides the base. On a rectangular prism, it does not matter. The remaining sides are lateral faces. In the triangular prism, so let me get my ability to write here, if I can remember where it is. Nope, I don't want to send it. You're not going to let me draw on it, are you? Come on. Nope, not seeing my pen. Oh well. So the triangular prism, because there are 2 triangles, those are the bases. The 3 rectangles that connect them are the lateral faces. On the pentagonal prism, because there are 2 pentagons, they are the bases, you see there are 5 rectangles connecting them. And on the cube, again, it doesn't matter if you call the top and bottom the bases, or the front and the back, or the left and the right sides. Whichever pair you choose to be the bases, the remaining sides are all lateral faces. So some of what you're going to be asked to do in this section is to identify 3-dimensional shapes, as in example 1 here. So they have us a polyhedron here. Every face is a polygon. There's nothing curved. So this is a polyhedron. Okay, we're not worrying about it being a right prism. All of our prisms are right prisms. You don't need to tell me that. There are 6 rectangles connecting 2 hexagons. That means this is a hexagonal prism. And you can see it says a right hexagonal prism when it spells it out there. You don't need to tell me right. Hexagonal prism is good enough. On the next page, we get some examples of other shapes. So here we have a sphere. Y'all know what that looks like. We have a cylinder. Okay, a cylinder has 2 bases. They're the circles. And what your book is going to call a curved lateral surface. Curved because it's, curved. Lateral because it's not the base. Same thing on a cone, except for a cone only has 1 base, the flat circle on the bottom. The remaining bit is a curved lateral surface, but a cone has a vertex at the top. Cylinder does not. It has a circle on top. Cone has a vertex on top. And then a pyramid has a shape that is a base, and all of the remaining sides are triangles that fold together to meet at the top. Okay. Here is a square pyramid, but you can have a pyramid with any polygon on the bottom. So in example 2, you can see we have a 5-sided shape on the bottom, so it's a pentagonal something or other. Because the other faces are all triangles that come to meet at a single vertex at the top, this is a pentagonal pyramid. I invite you to pause the video here and to try the examples. I'm going to do the practice problems in this video as well. So pause it, try the practice problems, which are numbers 1, 2, 3, 4, 5, 6, and 7, and unpause it when you're ready to hear the answers. For number 1, that figure it right. So they tell you its faces are polygons, which means it's a polyhedron. It says its lateral faces are rectangles, and it has 2 congruent rectangular bases. What I want you to see is that there are 6 rectangles here, which means it's a rectangular prism. On number 2, we've got a single circle, comes to a point at the top, that's a cone. On number 3, we have a square at the base, and 4 triangular sides that come to a single point. That is a square pyramid. It is a polyhedron. Please note that the directions say to name the figure and tell if it is a polyhedron. This is a polyhedron. All of its faces are polygons. Number 4 has 2 hexagons connected by a bunch of rectangles. That makes it a hexagonal prism. And it is also a polyhedron because all of its sides are polygons. Number 5 is a sphere, and it is not a polyhedron because it has curved parts. Number 6 has a triangle on the bottom, and then 3 more triangles connecting to a point at the top. It can be a little difficult to see the triangle in the back, I understand. This is a triangular pyramid, and it is a polyhedron because all of its faces are polygons.